Good evening, students. Today we're going to be working on lesson 3 in our book of chapter 8, which is all about energy transformations and conservations. When we left off, we were talking about the different types of energy associated with the particles inside of objects. Particularly, we were talking about thermal energy, electrical energy, chemical energy, electromagnetic energy, that's the one we use the glasses, and we were talking about nuclear energy. But now we are moving on, and we're going to learn today how are different forms of energy related, and what is the law of conservation of energy. First of all forms of energy can be transformed into other forms of energy. A change from one form of energy to another is called energy transformation, which makes sense. If you're changing it from one form to another, you are transforming it from one type to another. So some of these energy changes involve a single transformation or transformations, while others involve many or multiple transformations. And if you're following along in the book, this does start on page 294. You have a great My Planet diary that you can do, or you will be doing later, on roller coasters and amusement parks. You kind of reflect on the past when you've either been to an amusement park or seen amusement parks on TV, and throughout this lesson, you will be able to use what you remember about him to help see how energy transforms from one type to another. As you can see, I included a picture of a electro power plant. And this shows multiple transformations. And by the end of this lesson, hopefully you'll be able to recognize some of it. Now, single transformations. So sometimes one form of energy needs to be transformed into another to get work done. For example, a toaster transforms electrical energy to thermal energy to toast your bread, which makes sense. When you put the piece of toast inside of a toaster and you put it down, the toaster thinks it's very hot. But what's actually happening is the electricity is being converted to thermal energy. The last lesson we talked about what thermal energy was, we talked about what electrical energy was. Now we're talking about how they could turn in from one type to another to get the work done. This happens also in a cell phone. A cell phone transforms electrical energy to electromagnetic energy that travels to other phones. Your body transforms chemical energy in the food that you eat to mechanical energy you use to actually move your muscles. And a large portion of 7th grade will go over the muscular system, or if you remember 5th grade, is about how the energy inside the food is converted. Okay, so that's something we can look forward to later on down the road. Chemical energy in food is also transformed to thermal energy your body uses to maintain its temperature. Let's talk about multiple transformations. Now, multiple transformations, I put just 295. If you can, I'd like you to look at 295 while I'm going over it. So much of it was just so important, so this would be what we'd call in class notes. So often a series of energy transformations is needed to do work. For example, the mechanical energy used to strike a match is transformed first to thermal energy. Thermal energy causes the particles in the match to release stored chemical energy, which is transformed to more thermal energy into the electromagnetic energy you see as light. And I put 2 pictures of cars here because cars use multiple transformations just to go. Okay, to go 60 miles, to go 2 miles. Okay, to go 100 miles an hour, or to go 5 miles an hour. It's using multiple transformations. The thermal energy of the spark, when you actually turn the ignition, turn the key, releases chemical energy in the fuel. The fuel actually, what it does is it expands and is broken down to smaller particles. The expansion of the fuel produces pressure on the parts of the car. The increased pressure eventually causes the wheel to turn, transforming chemical energy into mechanical energy. So a simple way of putting this is that inside of a car, if your car takes gasoline, it's called a combustible engine. There's tiny explosions that are happening inside that engine. And those tiny explosions cause pressure to build up to make parts of the engine move so that your wheels will move when you give it the gas. And that's why it's called giving it the gas, to make the car move. because you're creating more of an explosion. You're releasing more energy as that fuel is being burnt up. Let's talk about how this relates to kinetic and potential energy. Reminder, the kinetic and potential energy, the sum totals of all that, is called mechanical energy. That's just a review from last lesson. You can have mechanical energy and not have potential energy. You could have mechanical energy and not have kinetic energy. Because mechanical energy, by definition, is the sum total of all the kinetic and all the potential. This is where we first talked about the pole vaulter in the last two lessons ago. So the most common energy transformation is actually the transformation between potential and kinetic energy. The transformation between potential and kinetic energy is the most common. For example, when you stretch a rubber band, you give it elastic potential energy, and when you let the rubber band go, it flies across the room. We did an example of that in one of our classes not too long ago. But also, as we learned with the pole vaulter is running down the track. They are moving, and that movement is kinetic energy. Okay? When the pole vaulter spikes that pole into the ground, all that kinetic energy is then converted to potential energy because the pole is bending. Okay? And when it gets that maximum bend, the potential energy gets released and it moves and it's back to kinetic energy. And the pole vaulter himself or herself is flung into the air. Okay? That's kinetic energy again. When the pole vaulter gets all the way to the top, as far as he or she's going to go in the air, at that point, that pole vaulter has potential energy. We called it gravitational potential energy. The pole vaulter will then fall down to the crash pad and land safely, hopefully. And that is kinetic energy. And that is the most common type of energy transformation, is between kinetic and potential energy. There's so many examples of that energy transformation that happen around us all the time. So speaking of energy transformation and kinetic potential, you'll notice the pendulum on this slide. And this is called Newton's cradle, but I got a better version of it. I got a GIF image of it to actually show the particles moving, and you can see the particles moving from left to right, right to left as it's hit. A pendulum swings back and forth. At the highest point in its swing, the pendulum has no movement. As it swings downward, it actually speeds up. The pendulum is at its greatest speed at the bottom of its swing. As the pendulum swings to the other side, its height increases and its speed decreases. At the top of its swing, it comes to a stop again. And what's neat about this one is you can actually see the particles moving of the energy as it's moving left to right. Now, we've talked many times about the fact that energy can't be created or destroyed, but we never actually learned about it. But I've been bringing that to your attention ever since we finished last chapter. This is known as the law of conservation of energy. The law of conservation of energy states that when one form of energy is transformed to another, no energy is lost in the process. According to this scientific law of energy, energy cannot be created or destroyed. So what happens to the energy? Think about it for a second. It can't be created or destroyed, but we know we use it. What happens to it? Well, it transforms from one type to another. It could go from thermal energy to electromagnetic energy. It can go from electrical energy to thermal energy. It could go from potential to kinetic. It just transforms. We just talked about it with the pendulum. As the pendulum swings, it encounters an energy transformation. So if you add up, or look at, the pendulum swinging, what happens to the energy once the pendulum stops moving? Well, as the pendulum swings, it encounters friction at the pivot of the string and from the air through which it moves. Whenever a moving object experiences friction, some of its kinetic energy is transformed into thermal energy. So the mechanical energy The sum total of all the potential kinetic energy of that pendulum swinging is actually not destroyed. It's transferred into thermal energy. The fact that friction transforms mechanical energy to thermal energy should not surprise you. After all, you take advantage of that, such as when you rub your hands together when you're cold to warm them up. Friction is the reason why no machine is 100% efficient, because some of the energy is lost due to heat. We talked about friction before. We actually covered it for a good long time. I brought in those examples of those two tires. One was brand new. One had been used for a long time. And we saw how friction heated up the tire. Reminder, friction creates heat. And some of the tire tread was lost. That ends chapter 8, lesson 3. Stay tuned for lesson 4. Thank you.